Hello, everyone. Can you hear me well? Okay, great. So welcome to this next installment of the Axiom Programming School webinars. And today we are going to be covering a little bit about how to make Scala a little bit more practical, because so far what we have been doing is working with Scala as from a web interface. So we had this Scastie scene, and this Scastie allowed us to write some code and execute the Scala code. But obviously, what you would like to do is do that not from Scastie, but from your local machine, or maybe you would like to do that from a machine that hosts a website. If you're making a website, for example, it will not live on your machine, it will live at some server, for example. And if you want to make a website with Scala, you want to have Scala on that machine. So by now we have more or less enough knowledge about Scala to start doing something useful with Scala, something like implementing an actual search engine for flights or similar. So today we are going to lay a little bit of groundwork about that, about how to do that with Scala. And the first step on the way of this groundwork will be to have a local installation of Scala and see how we can run Scala locally, so on your machine without Scastie. There are also a few other pieces that we will need to cover, such as other people's libraries. So if somebody else wrote some Scala code to do something useful, how are we going to make use of that? Also how we are going to make sense of that code, how we are going to communicate with that code, and so on. So if we have some time today, we are also going to cover that. Okay, so without further ado, let's get started with the local installation of Scala. So what we can do is I can share my screen. Okay, so you should see my browser. So to work with Scala, we will to work with Scala locally, we will need something called VS Code, with text as a text editor for writing code locally. So if previously we had Scastie to write code in, and Scastie had some nice features such as highlighting of the syntax, like all the keywords have different color, and it also had this ability for us to see what the program does, so the program output. So if you had that in Scastie, then it makes sense that if you want to write Scala locally on our local machine, we would like to have something like that also on our local machine. And this is exactly what Visual Studio Code does, which is a code editor, of choice for Scala. So you can, if you Google for VS Code or Visual Studio Code, you will end up on its website, and then you can download it. And I'm not going to download it because I already did, but you download and install it as any other program. And by the way, all of those instructions that I am saying, they can also be found on the Scala main website. And the reason I'm not showing you those instructions is because we are going to follow a slightly simpler route, because there are many different ways to run Scala. So we are going to pick the simplest way to write and run Scala. But the point is that once you have VS Code installed, then what you can do is, open it. I'm going to share my entire desktop for you to see. Okay, can you see VS Code open on my machine? Great. So this is about the interface that you will see. And VS Code is an editor. Essentially, it is a text editor. So you can create a new file and you can start writing something in that file. And so the way we usually work with Scala is we have a directory where all the Scala files exist, and we work with those files in a code editor. But as you remember, in Scastie, we were able to get some help from editor itself. So if you go to Scastie, for example, if you go to Scastie and start writing code in Scastie, so if you do the new file, if you write, like for example, some random function, so f of x int equals x times x. So as you can see, we have the text in different colors. So the keyword will be yellow, the names will be bluish, and the types will be a little bit greenish. So it means the code editor, it understands the language, and it knows what to color in which color, so that it is more convenient for us to read. This is not the only thing that a code editor provides. So for instance, there are things like code completions. So if you write, for example, if you have a variable of type integer, and then you say x dot, well, it should have done some completions here. So it should have, after this dot, it should have displayed what else I can write. But currently it doesn't do that for some reason. That is probably a bug in Scastie. But my point is that a code editor, it is supposed to be more than just a text editor. It is supposed to provide the programmer with all kinds of assists on writing code. And this is achieved in VS Code. It is achieved by extensions, because the thing about VS Code is that it is a code editor that you can use not only for Scala, but also for any other programming language. And before you can use it with Scala, you need to teach it that there is such a language as Scala. And the way you do that is by the system of extensions. So as you see on the left-hand sidebar over here, we have the various buttons, and one of them is extensions. And you can see a lot of various extensions. Well, in this case, there are installed extensions that I have on my machine that extends the functionality of the editor in one way or another. So what we want here is to type Scala in the search bar, and then there will be this Scala metals extension that we want. There's also this Scala syntax extension that I have also installed here, but I believe metals it incorporates Scala syntax as well. So metals is not only syntax highlighting, it is also things like real-time error checking. So for instance, if you type stuff in metals, if you type stuff and you make an error, then it will tell you in real time that you have made an error. So you do not need, well, in Scastie, you need to click run, for example, for it to tell me that I made an error. Like for instance, I write print line y, for example, and I hit run. Then it is going to tell me an error once I run this code. But with VS Code, with metals, it is going to tell me right away without even running the code. I have already installed it here, but if you do not have it installed, then once you find it, instead of those buttons that I have here, you will see the install button, after which you just click this button, and it is going to install you metals. And from that point, whenever you open a Scala file, it is going to show you the completions. Well, it is going to be easier to work with that file, basically. And by the way, one caveat that you might encounter is that there will be a notification at the bottom right corner of the screen over here. Once you install metals, it will ask you to install something else that is needed for it to work, which is a Java virtual machine. It's not important what exactly it is, but it is important to know that when you install it, it might ask you to install something else, and there will be a button to install it. So just click that button and agree to that, and it will work. So the way we are going to work with Scala is we are going to create a new directory, which will be a workbook. And there we are going to be working with Scala. And by the way, if you have any questions about the text editor, about the VS Code, about the extension system, about anything like that, feel free to ask in chat. And in the meanwhile, I'll keep explaining. So once you have created the folder which is going to hold all of our Scala sources, and by the way, I'll disable notifications. So once you have created this workbook thing, this workbook folder, what you do is you open it with VS Code to see all the files that it contains. So to do that, you drag and drop it onto the VS Code. And then you see that VS Code, it has this big getting started window, which I can close. And to the left, it has Explorer. And in Explorer, we have the workbook open, and it is a directory. So I can create new directories inside of it. I can create new files inside of it. So maybe I'll maximize VS Code thing. And so the Scala code, it lives in files with extension Scala. So I'm going to create a new file, and I'll call it hello Scala. And then I write .scala. Now, do you know what are extensions, like file extensions in operating systems? Like when I write hello Scala.scala. So are you familiar with what .scala part is, like the extension part? Or do I need to clarify that? Okay, so maybe I can clarify a little bit about extensions. So I'll maybe open the whiteboard here. So okay, it works. So well, as you know, there are files on your computer. Like files is how you work with computers. So and there are different kinds of files. So there are files that contain an image. There are documents where you write, for example, a paper or a book or something else. And there are the files that you can run, like computer programs, which I'll write like this. So runnable programs. And the question is, how does an operating system differentiate the types of the file? Like, how does it know when you click on an image to open you a program to display images? How does it know that when you click on a Word document, how does it know that it is a Word document and displays you the Microsoft Word or another editor program? So the question is, how does it know that? And the answer is, it knows that by looking at the name of the file. So the files, they have names. So this one would be like, for example, photo. But the crucial part is that every file, it has an extension. So every file, it has a name followed by a dot and then an extension, for example, GPG. And the extension, it is going to tell the operating system that it is an image. If you have, for example, a text document, it will be like paper.doc. So by this extension, it will know that it is a Word document. And depending on the settings on your machine, you may or may not see those extensions on your files, but they're always there. It is just possible to configure your operating system to not display them. But all the files, they have extensions for the operating system to be able to tell what to do with those files. And the extension is the part after the dot. So the name of the file, dot, and then extension. Does that make sense? Okay, so moving on to our stuff. The question is, how do we know that in a given file there is a Scala code and not Python code and not Ruby code and not code in any other programming language? And the reason we know that is because the Scala files with Scala code, they end with .scala. So they have the extension Scala. And while we were talking, we see that something happened, a lot of things happened in the editor. So first one, when we named the file, when we named the file and entered that it is a Scala file, so we set the extension .scala. Then, as we have just discussed, the programs working on your computer, they knew that you created a new Scala file. And because we installed Metals, and Metals is a software that assists you to write Scala code, Metals saw that you have created a new Scala file, and it started preparing to assist you to write in that file. So that's why we see that this output window got opened, and you see a lot of text written over here. So this text, it's what Metals wrote when it started up. So you see, like, started Metals, blah blah blah, and Metals, it wrote here all the telemetry, so that you know, as a programmer, what happened during the start. I mean, you don't need to read that, you don't need to understand that, you just need to see that it happened, that Metals got alive and ready to help you write the code. So that's good. And also you can see that in the Explorer section, in the workbook folder, when we created the Hello Scala file, we see that there are two new directories that got created automatically. So there is Metals and there is VS Code. And so what happened here is that, again, both Metals and VS Code, they started to prepare themselves for you to write Scala code. And as part of this preparation, they need to store some information on your machine. Like, for example, one function that Metals provides. Metals is a code analyzer for Scala. So what it does is it tries to understand what you wrote. And then based on that, it provides you all sorts of assistance. And understanding code is a time-consuming process. So you don't want to do it if that is not necessary. So, for instance, every time you start your code editor and want to work on your project, if every time that takes like 10 minutes to get started, you're going to hate such an experience and you're going to switch to another language, right? Because it's very slow. So to avoid such kind of situations, Metals, it does the code analysis only once, and it remembers what it understood under the Metals directory. So .metals is the default name of this directory, and here you see that it creates a bunch of files that, again, as a programmer, you do not need to understand those files. You do not need to look in these folders at all. It's just for your understanding that why those folders exist and how they came into existence. Also, as you can see, when we clicked on those files, sometimes VS Code does this pop-ups that say, like, for example, the marketplace has extensions that can help you with DB files. So again, we do not need this now, but just to be aware, VS Code, it tries to understand what you're doing. So when I opened the file with extension DB, it understood that it cannot help you to read this file, but there are extensions that can help you read this file, and it showed you this pop-up over here. But we do not need read this file. As I explained, this is a technical file that we do not need to touch. So I'm going to close that. And well, that's the way it works. Okay, so we have a question: why do I not get metals in my workbook? So, well, I don't know. It depends on your setup. And I think if you're trying to follow that along with me, then you need to make sure that you have first metals installed. So again, in the extensions, you have entered metals, and you have installed it over here. And if you have done that, then you need to make sure that you have created the Scala file. And if you still do not get those two folders, it might be that the operating system hides those folders from you because they start with a dot. So folders that do not have a name, folders that do not have a name but start with a dot, usually by default they are hidden. So I mean, do not worry if you do not see those two folders. They're technical files and they'll appear as you go. In fact, I think it's strange that I can see them here because usually they are hidden. But the important stuff is that you can create the hello Scala file, hello Scala.scala file, and it has the Scala icon to the left so that you see that it is a Scala file. Does it make sense? Also, once you create the Scala file and open this file, do you have anything in the output section of the code editor? Like this output that I have just shown to indicate that metals started up. Well, if you do not get the output, if you do not get the output section, then you might need to restart your code editor. But I mean, it might take it might not work from the first time, and the important thing is not the output screen, but whether or not the you can create the Scala file. And when you start writing in this Scala file, if you write, for example, def f of x integer equals 100, for example, you save this file, that it shows you the code highlighting. So def is red and f is green, and so on. So that is the most important thing, because otherwise the output and the two directories that we have created, they are more technical things. Even if you do not have metals started, the important thing is that you get the code highlighted, because so far we do not need the fully fledged functionality of metals, such as error reporting as you type, because we are not going to use metals to actually run the code. We are only using metals as an assist. So as long as you can see the code highlighted here in the code editor, you can be sure that it worked. So do you see the code highlighting when you type? Okay, so if it is highlighted, then it should be good, because if well, for this lesson we do not need the fully fledged functionality, but once you move to more advanced projects, you need to make sure that metals works. Sometimes it might take several restarts, but we will get there, and if it doesn't work, we will figure something out. But the idea is that so far, to run the Scala code, we are going to be using a special syntax in that code. So the thing is that if in Scastie you could write the code straight away and it will run. Like you could do, for example, print line hello Scala. Then for the standalone installation of Scala, it is not going to work. You need a special, you need to write the Scala code in a special format for it to execute. And this special format involves a so-called entry point. So programs, they consist of different functions. As we have seen before, you can define various functions. For example, def square, the function to square two numbers or one number can be defined as follows. But the idea is that, okay, sorry for those assists that I get here, but the idea is that the program can have not one function, but many functions. And you might want to have a fine-grained control on where do you start execution of your program. Because normally you do not write the programs as we have seen in Scastie, so you don't just write code like this, like print hello and it executes. Why is that not the case? Why do we not write the code that we are going to execute just in the Scala file, just from the top of the Scala file? Does anyone have any idea of why do we not do that? Why do we not write the code to be executed in just in the Scala file and expect it to be executed? Well, the idea is that in Scastie we were able to write the body of the program just like this, like print line hello, print line 2 + 2, for example. Well, the answer why we cannot do that is because we might have more than one Scala file in one project. Like, for instance, we have hello Scala file here that writes hello on screen and then sums two numbers. Well, what if our program, it consists not of one file, but of two files, like, for instance, file2.scala. And we also have something written here, like print line. For instance, this is file2. And the question is, well, I mean, it is a common practice to have the code distributed along several files. It's not very common at all in programming to have the program written in a single file, because programs usually grow big. And if you have a very big program, like, for instance, this one just has 6 lines of code. Well, what if you have 6,000 lines of code? It becomes very difficult to scroll it. So the thing is, to help us organize the program, we usually put different parts of the same program into different files, and then we run all of those files at the same time, so that the entire program is executed. So are these different files in one workbook connected? So yes, normally they are connected, but you need to connect them. We will see in the future how you can connect them in our setup, because there are various ways to connect those files. But usually if you have a directory and you have a bunch of files in some programming language in that directory, well, usually they are connected and usually they represent a single program. So if you go, for example, to GitHub. GitHub is a place where people write software, so where they write the source code of their programs and store the source code of their programs. So if we go, for example, to GitHub main page, and I'll just open some random program, And just to show you how software is usually organized, so you see that one program, it has not one directory but many directories, and every directory has subdirectories. So if you go, for example, to one of such subdirectories, we'll have a bunch of Scala files in there, and every Scala file does something, and there are a bunch of subdirectories, and every subdirectory, it also has Scala files, and every Scala file does something again. And the important thing is none of these Scala files lives alone, right? So they only make sense as a part of the larger program, as a part of this entire directory structure, of this entire mass of other Scala files, of this entire Scala program. So all of this directory structure, you can see all of those Scala files, they comprise a single Scala program, and none of those files, they can be treated alone. And this is a normal thing for any program. So virtually any programs that you can think about, the programmer writes them in terms of a directory structure which has many files, and each file, it has some little piece of the functionality of this program, and those files are all connected, so they are all treated as a single program. Does it make sense? So now back to our example. So the reason, yeah, so do they run in order? That's a very, very, very good question. That's exactly the point that I'm trying to make, is because if you have not a single file, but many files that comprise a single program, then the question is, how exactly do you run them? Is it like the code from this file is executed first, or is it the code from this file is executed first? And if you have 1,000 files, what exactly is the order in which they are executed, right? Well, this can be a very difficult problem to solve if you think about every Scala file as instructions for the computer to execute the code, right? Because if they're instructions, they execute in certain order. So to avoid this problem, we do not treat them as instructions. So it means that we make it illegal to just write logic without a name and expect it to be executed. So we cannot just write print line from the top of the file and expect it to be run. We cannot write 2 plus 2, 2 plus 3, for example. We cannot write this at the top of the file and just expect it to be executed, because then we run into the problem of having a bunch of files and then in which order those instructions run, right? So we are going to remove that, and this we are also going to remove. But we can write functions, we can define functions in those top level, in those files. We can define function square over here, and then we can write def cube over here. And then I have here a nice autocomplete here. So, and this doesn't confuse the computer. So if we have, for example, the function cube here and the function square here, and we have those two files as part of the single program, this does not cause any confusion to the computer. Why is that so? Does anyone have any idea in the chat? Also, the same thing happens if we, yeah, well, okay, maybe I'll just leave it as is. We can have another function, for example, def f of, or say hello. So my question is, why, previously we were running into the problem of in which order do the files run by the computer. And we argued that we only have this problem if we treat files as a sequence of instructions. So if we can put things like print line into the top of the file, we run into this problem. But if we disallow that, if we cannot put any instructions, but if we can still have function definitions in those files, we do not run into this problem. So why do we not run into the problem of the order of file execution when we have only functions defined in the files as top-level structures? I mean, why would that be? Do you have any idea? Yes, Olga says we should call these functions, and this is exactly right. So the thing is that if we just write those two functions square and say hello, they are never executed by the computer until you explicitly tell the computer to execute those functions. So if you try running the hello Scala.scala file, also we can do the same thing in Scastie, for example, just to refresh your memory. So if you go back to Chrome, to Scastie, and we put this code over here, if you run it, nothing is going to happen, right? Because we have defined two functions, but until we actually tell the computer to run one of those functions, nothing is going to happen. They're not going to be executed just because we defined them. Now, to run a function, you just call it as follows. So say hello. So in Scastie, you can do that because there is only one field where to write code. So it's unambiguous in which order to execute instructions. So function call is an instruction. So we call it. And since we call it as follows, then it is going to be executed. Otherwise, functions are never executed on their own until they are called. Does it make sense? So now it becomes more clear, I think, why exactly we do not have this problem if we have millions, well, not millions, but thousands of files, because it's unmanageable if it is millions of files. But if you have hundreds and thousands of different files, but they only have functions, we do not have any problem with the order, because if they're just functions, they are not going to be executed until you actually call them. So you can have hundreds, thousands of files, but it's fine because they are not called anywhere. But then the question is, in this setting, when you have multiple files, how does the program actually know where to execute from? And the answer is, well, we have a bunch of functions, and all of those functions, they do something. So why don't we have one of those functions, and why don't we say that this is a main function, and to run a program, it means to run that main function. So there is, in any programming language whatsoever, there is a concept of an entry point to the program, which is a function that is called first when we run the program. And this is where the execution of the program starts. So in Scala, for example, we might want to have, say, hello as the entry point, and to tell Scala that this is in fact an entry point to the program. What we do is we write add, and then we write main. And you can write it like this, or you can write it like this, it doesn't matter. But once you have this at main before the def, well, at main is called an annotation. It is called a main annotation, and this is how we mark the function as to be the first one to be executed. And now we can actually see how to run this program. So to do that, we see at the bottom of the screen this little window. If you don't have it, there is at the top right corner of the screen, you see those couple of buttons over here, and they all are responsible to toggle in various panels at the code editor. So for instance, this one, the first one is for the side panel. You can toggle the side panel as follows to make more space for writing code. There is a bottom panel, so you press a button like this, and there is a bottom panel. And then there is a sidebar, which is also some space that you can put stuff in. But what we need is to toggle the bottom panel, so like this. And then you see that there is a bunch of stuff at this bottom panel. And I have here the terminal, and I click this terminal over here. Now, if you do not have the terminal, well, there is what you can do is you can use a shortcut. On Mac, it is Command-Shift-P, and it will open you this little window. So the shortcut again is Command-Shift-P on Mac, and on Windows it would be Control-Shift-P. And what it does is it opens you this little panel over here. And this panel has various commands that you can run in VS Code. So this is like a control panel to your VS Code, from which you can issue various commands to all your extensions. So you can open things, like for instance, if you write file over here, you can see a bunch of things that you can do with files. Like for instance, you can create a new file, you can create a new folder, you can open a folder, you can open a file, you can save a file. So all of this can be done from this panel. But what we really want is we want a terminal. So we write a terminal. If you do not already have it in the bottom sidebar, so you would do the create new terminal thing. And this should give you the terminal in this workbook. And another alternative way of doing that would be, I believe, to right click at the workbook. No, I think it's not the alternative way. Let me just see if you can do, yeah, so you can actually do that also from the workbook scene, from the contextual menu. So you see, if you right click anywhere in the workbook, is it visible to you when I right click and I have the menu over here? Do you see the menu? Okay, so if you right click anywhere in this workbook, you see that it has open in integrated terminal entry. And if you click that, it's going to give you a terminal which we are going to use. Well, I'll show you how we are going to use it. So if, for example, I do not have this terminal over here, I do not have it over here, so I can close this terminal at all. Well, you should be able to get it by clicking the toggle panel button. But if you do not get it, if you do not have the bottom panel, another way to do that would be to right click at the workbook at this Explorer thing, and then open in integrated terminal. Now, well, the next question would be, what is terminal? Does anyone know what the terminal is, and has anyone encountered terminal before? Okay, so terminal is otherwise known as command line. It's like a tool that programmers use virtually every day, and it is essentially a text interface to the operating system. Like, for instance, what do you usually do to create a file? Well, to create a file, you usually have program that allows to do that. So for instance, if I'm in VS Code, I can click this button over here, this page with plus, and it's going to give me a way to create a new file. I can have a new text file, like for instance, hello.txt, and I can write something in this file, foo bar. I can save it, and then I can create a directory. If I want to create a directory, I can click this button over here, and I name it somehow, text, for example. And then how do I put this file to this text directory? Well, you drag and drop it, right? So you drag it, drop it here, and then it goes here. So this should be familiar to anyone who used computers. But the thing is that it's not the only way to do that. And a long time ago, when the computers just started, we didn't have those graphical interface at all. We didn't have the windows that we can open, that we can close, that we can use with our mouse, that we can click on with our mouse. In fact, we didn't have even a mouse back then, and we communicated with the computer using text only, and the mode of communication was using commands. So it's a little bit as a chat, like a chat application, except that we are chatting with a computer, and we are like, our messages to the computer is what it needs to do, and the computer's messages to us is the result of what it did. So for instance, if it succeeded in what it tried to do, if it failed, and why it failed, and so on. So it resembled a little bit a chat between us and the computer. So the terminal is exactly that. It is a chat application with a computer, where you can tell the computer to do stuff, and it is going to do that stuff. So let me give you a simple example. So here I have this terminal open. So these 3 lines over here, it's just technical stuff. You may or may not get the same, but it's just the technical stuff that is there every time the terminal starts. Then we have this line, the last line. What we have here is some text, which, well, base over here, I'm not even myself sure what it is, but it is there. I think it is there. Yeah, I'm not going to try to explain that, but I mean, it's technical information about the terminal being opened. What is more interesting is what goes a little bit next. So we have this workbook over here, and it means that this terminal, whatever we are going to tell it, it's going to do those stuff to this directory that is open over here. So if it says workbook here, it means that the terminal is aware that we are in the workbook directory, and whatever we tell it to do, it is going to happen in this directory. And then we have the, well, this in our case is the name of the user. So in my case, it is Kmetyuk. So that's the name of the user under which I am logged in. So basically the location where the terminal is opened and the name of the user. And by the way, the lamp XX over here, it's the name of my computer. So it has the name of my computer, the name of the directory, which is going to be concerned by all of our actions, and then the name of the user. And then we have this cursor over here after the $sign, and that's where we can write anything we want. And we can hit enter, and the computer will try to understand what we did, and it is going to tell us to tell us something back. So in this case, what I did is I entered some random text, and then it tells me that, well, this random text command not found. So it didn't understood what we said. But there are things that it can actually understand, which I'm going to show you next a little bit. So does it make sense so far about the terminal? Any questions so far? Okay, so let's see what we can actually tell the computer to do via this command line interface. Well, first thing that we can do is we can ask the computer what things exist in this directory. And by the way, this is just a demonstration. The commands that I'm going to enter here, you do not need to remember. So far, I mean, it's good for you to learn some as time goes. I'll show you where, but I'm just showing you the concept of the terminal and what it does. And we are going to need only a single command just to compile the file, but I'm going to show you that later. So for instance, we can ask the terminal about what this current directory contains, and this is done via ls. So ls stands for list. If you hit enter, we're going to see all of the files that are in this directory. So file 2.scala, hello scala.scala, and text, which is a directory. And it doesn't show us those two directories with dots because these are hidden directories, but we can make it show. So next thing we can do with it is we can tell it to create a new file. So for instance, if I do touch, and then after touch, I have the name of the file, for instance, foo.txt. So touch is the command, and foo.txt is the argument to this command. So if I hit enter, we see that there is a new file appeared, foo.txt, and it is an empty file, an empty text file. And what we can do is we can write stuff in that file. Again, we can do that via graphical interface, but we can also do that via command line over here. So let's see, this is an empty file. And then I close this file, and then here I do echo. And then, well, echo by itself, it's going to write to the command line, but whatever we say. So we write echo, and then we write what we want to write in that file. So we write, for example, hello from the terminal. Write that, and then we are going to need to specify where to output it, where to output this text. So we do that by the greater sign. So greater sign, and then the name of the file, which is foo.txt. We hit enter, and then next time we open this file, we have hello from the terminal written. So that's another useful thing. Now, what about making directories? Well, we can do that as well. Make dir, make directory, and then the name would be like, for instance, terminal dir, terminal directory. We hit enter, and then it appears over here. It's empty. What if we want to move a file into the directory? Well, there is mv move, and then first we write what we move, which is foo.txt. Then we write where we move it, which is terminal dir. We hit enter, and then this file disappeared from here, and it appeared over here in the terminal directory. Well, next, what if we want to clean our mess up a little bit? So terminal directory and texts, those two directories. What if we want to clean that? Well, what we do is rm, which stands for remove. Then if you write terminal directory and hit enter, it says, well, terminal directory is a directory. I cannot remove it. Why is that? Well, because directories, they usually contain a lot of stuff. And if you make a mistake, it's not going to be good. So what you want actually is rm-r. So -r over here, it stands for, well, it doesn't matter what it stands for, but what it says that rm, remove, is allowed to remove directories. So it means that you know what you're doing. You allow the terminal to remove directories. Now, if you do terminal dir, then it's going to remove it. Then if I hit, if I also want to remove the texts, I can do that as well. So rm-r, terminal or texts, and then it's going to remove texts. So this can be a little bit overwhelming. All those commands, they might seem like black magic, and it's no wonder, because they have pretty obscure names and obscure syntax to write them, and they're in general pretty obscure. But the good news is that we do not need them right now. All we need is a single command with which you compile Scala files, with which you run the Scala files. So now I'm going to clean up this mess a little bit by hitting Command K to clean up the terminal. And I'm going to show you the single command that you need, which is Scala-CLI. Well, CLI, it stands for command line interface. Command line is the terminal, and interface is, well, something that you can interact with. So Scala-CLI, it is a program that allows you to interact with Scala using command line. So you write that, and then you write the name of the file that you want to, well, run, which is hello scala.scala. You hit enter, then it's going to compile stuff, and then it's going to, well, write hello world. So why did it write hello world? Well, because there is a function in this file that we have run, which is say hello, and it is a special function because it has this .main, this @main annotation in front of it. And so what Scala-CLI is going to do is it is going to look through the entire file, all the functions that are contained in this file, and then it's going to pick a function that has this @main annotation, and then it's going to execute whatever is inside that function. So if you have println hello world, if you have, for example, println square2, and then we're going to run it, and then it's going to write first hello world, and then well, 4, because square of 2 is 4. So that's the way it works. And then, well, just to illustrate the point of the necessity of main annotation, what happens if you don't have it, if you remove it and try to run the same thing, then we have an error because there is no main, well, it says no main class, but we understand no main function because that's what it actually is. It is main function, it is not a class. The reason it says class has, it's for historical reasons. So now if we have two main functions, let's see what happens then. Then you shouldn't be able to decide which one to run first. So if you run it, then it is also an error because it is confused. We have two main functions, but there can be only one entry point to the program. It shouldn't be ambiguous, otherwise it doesn't know what to do. So it only works if we have one of these main annotations. And by the way, in the terminal, the way I immediately get, you see, I immediately get this Scala-CLI hello Scala thing. Why is that? Well, because I click on my keyboard the arrow up. So if I click arrow up, I'm going to see the previous things that I ran. If I click arrow down, I see the, I scroll down the history. And that's the way it is. So that's the way you compile a Scala file. So does it make sense so far? If anyone tried that on your machine as well, then let me know if it worked on your machine as well. And I'm not completely sure if I tied those two files together. So let's see if what happens if you run the two files together. What happens if you have the cube over here instead of the square? So the cube comes from a different file, and if we run Scala-CLI hello Scala, then we're going to get an error. The compilation failed. The cube not found. Why is that? Well, because we specified only one file. So if you have two files, we need to specify both of those files, file 2.scala, and then it should work. So yeah, now it works. So if you have several Scala files, then you need to specify them as part of a single command. And if you have some errors while doing that, then feel free to post them in chat. I'll tell you what went wrong. So yeah, obviously, if you have multiple files, it's you're not going to specify them by hand like that, but there are different techniques to tie many files together into one program. But so far, we have this technique. So that's that for running the that's that for running the Scala programs locally. So if you have the Scala CLI is not recognized error, then it means you didn't install Scala CLI. So you need to, what you need to do is, yeah, probably I didn't, yeah, right. I didn't tell you to install Scala CLI, right? So I'm going to share my terminal over here. So again, to install Scala CLI, you Google install Scala CLI. You get the main website of Scala CLI. And then you scroll until you see the install Scala CLI scene over here. You select the operating system. You select download Scala CLI for your operating system. Like for Windows, it will be a file that you start and you install it. Mac OS, if you have Mac OS or Linux, then you it will give you a command, a terminal command again. So through the terminal, many of the things that we do as programmers, we do from terminal. So you select this command, you click copy it. Then you go back to your terminal, which I have over here. I am going to paste the command in the terminal, and it's going to run. And for me, it's not going to do anything because I have it already installed. But if you do that, hopefully it's going to work. And once this is done, like I'm going to cancel it right now, cancel this execution because I have it already. But once this is done, what you do is you close your VS Code, then you start it again. Then you're going to, well, open the workbook folder again, where you work in Scala. And then in the terminal, hopefully it should have the Scala CLI command. So hopefully when next time you write Scala CLI, you do hello Scala, then it's going to work. So does that make sense so far? Okay, so that was what I wanted to show you today. So how to run the Scala programs locally. So this is a pretty powerful thing to do because in Scala CLI you can only have one editor space, and then so you are limited in the amount of code you can write. You cannot split it among several files. You cannot save it. Well, you can save it, but it's not that convenient. So it's not good for big projects. So for bigger projects, for ongoing projects that you work every day, you should have a setup like this. So next thing that we are going to cover during the subsequent lectures would be well, how to interact with other people's code, because I mean, what you might want to do is to, for example, fetch something from the internet, fetch like, for example, flights data from existing database, which is free and available for everyone to use. Like I can show you something over here. If you enter, so all of the services online, they are built on communication. So they communicate one with another. For example, if you are building a program that is about searching for flights, or you're building a trip planner, you're not going to implement from scratch the functionality to actually search for flights, because somebody has already done that before. And the way it works is via the system of so-called APIs. And if you Google for API, you see that API stands for application programming interface, which sounds very smart, but it's if you analyze what it means actually, like what is application programming? Well, it is an act of making a program. So a programmer sits down and makes a program. And interface, it means how different things interact one with another. A protocol of interaction, rules for interaction, which means you have one program and you have another program, and how one program calls another program. So as a programmer, how do you call another program? That's what API, application programming interface, means. And that is pretty powerful because there are various free APIs online that do various stuff for you. So to illustrate, I'll Google for awesome APIs, and awesome APIs is it will give us a GitHub page, and this GitHub page is going to have a list of APIs that are available either for free or not so for free. So you can see, well, maybe I'll pick up another awesome API project, which is has a nicer table of contents, because various people make those table of contents and of various APIs that you can use. Like, for instance, what you can have APIs for finance, you can have APIs for events, you can have APIs for health, for government. For instance, if you're interested in food and drinks, if you're making some travel application, you can see what other people provide, what building blocks do other people provide to build something around food and drinks. You have this list over here for various services available online to do something related to food and drinks. So, for example, data about various grocery products and food. You can click that, and you see it's a service which is hopefully has a free tier, which is limited, but I mean, there are lots of those services that you can find for free as well. But the point is, you can do something with it. So if you click documentation on one of those services, you will see what exactly you can do with it. So, for example, like here is a documentation for what you can ask this service. So it's also built around asking questions and getting responses. And there is a proper format to ask the questions, but you can get an idea from the documentation at the high level of what it does. Like, for instance, you have here, get a barcoded, get a branded food item using a barcode. So it means that probably you can enter the barcode into this system, and then it will tell you something about this product. You see that there is a response in certain format, and it has some information inside of it. For the moment, we are not going to stop on the format of this information, but there is the point is that it contains some information. We will see how to work with such kind of stuff later. But the point is that it has here ingredients, for example. So it means that, I mean, it will tell you the ingredients of a product using its barcode. It has a brand, it has a name, it has a quantity, it has a size of the package, it has a number of servings, blah, 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 all this stuff in some formats that you can later think about how to parse. So this has some nice consequences. Like, for instance, if you're building a startup around nutrition, for example, you can have an application for mobile phone that uses this service over here, and you point your camera on a barcode, for example, and then it sends this barcode to this API, and then it's going to tell you the ingredients of this application. And then you can do what you can do, for example, see if those ingredients, they have some allergies, they trigger some allergies for the person that installs that app. And this is just for food. I mean, and this is just one service for food. Like, for instance, you can have something funny, some funny API. You can have, for example, this coffee. It says random pictures of coffee, which is something funny. If you click random coffee here, it has, if you update this page, it will give you random coffee pictures. Not sure why this might be useful, but you can call it from a computer program. All of those things to do with food. You can go back to the top of the page, and you can see, like, for instance, we were talking about flight, right? So maybe we can go to transportation, and then maybe we can go to where we see aviation API, for example. It's aeronautical charts. It doesn't have flights. If we enter, for example, flights, there's some space flights. compare flight prices, for example. There you go. Compare flight prices through platforms. So probably it's something similar to what we were building, like a flight search engine. So it takes us to the page, which will hopefully show us some documentation with what we can do with this. So we have two things that we can do. Start flight search, for example. This might be interesting for us. And then here is some documentation in certain format that allows you to search for flights. So there are parameters. So think about it as function call. So it's like a function call in Scala. For instance, we should have here somewhere to enter the city, which I do not see. We see destination city. I do not see the departure city, but probably there should be somewhere. Yeah, city 1 here. So you enter the code of the airport where you depart. You enter the code of the airport where you arrive. All of this is specified as this documentation, and you should be able to call to. There is a format to call the APIs from a Scala program, from any other programming language. And we are going to say a bit later how exactly to do that. But the point that I'm trying to make today is that there are various services online, third-party services that provide you a lot of useful capabilities. Most frequently, they are not free. Most frequently, they have a free tier. But most frequently, you don't care if you're building some commercial application, because the commercial application is going to pay for those services. The point I'm trying to illustrate is that it's not enough to just know the programming language. You need to know how to interact with other people's stuff, because the modern programming environment, modern tech environment, it is not about some single cool developer just single-handedly doing all the cool stuff. It's not about that. It's about making, it's about collaboration. It's about finding all the right pieces and gluing them together for them to work together. And APIs is just one way you can do that. Another way is libraries. So if I search for awesome Scala, you will get some Scala-specific tools to work with Scala. I didn't. So other people created some awesome stuff, some nice stuff to do stuff in Scala. So you see here some categories. So there is concurrent computing, there is big data, there is computer science, there is for API calls specifically. To work with APIs, what we would like is some kind of web development scene. And here we would like some kind of something to call those APIs, which I do not see right here at the moment. But we are going to see that later. That's not the point. The point is that there are many tools to do various stuff in Scala. So the point is you do not need to write your own solution very frequently, because other people solved the problem for you. So it's very important to know what is out there, and it is very important to know how to work with all of this. And you might be confused that there is a lot of stuff available, but the good news is that most frequently they follow the same format. So if you know how to read the format, and if you know how to learn, if you know how to use one of those tools or one of those APIs, then chances are it will get much easier onboarding on any other tool and any other API you might encounter. So that is what we are going to be concerned during the subsequent seminars. We are going to see how to use Scala to actually build stuff, and in the meanwhile pick up a little bit more about the Scala programming language as a language. And so far, if you're interested in exploring Scala on your own, because from now on I think it's good for us to focus on seeing how to build stuff with Scala, but if you're interested in exploring more Scala in depth as a language, you're welcome to go to Scala website. So if you Google Scala, then you're going to go to the Scala programming language, and there is a Scala book over here. If you click the Scala book, it's going to, well, give you the Scala book. You can read it and you can see what's available in the language. And if you go to Learn Scala, you're going to have even more resources. So you're welcome to explore Scala on your own. And during the subsequent seminars, we are going to be encountering various Scala concepts again, but we are going to spend less time on the particular concepts, but more time on actually using Scala to build stuff. So that's what I wanted to talk to you about today. And I don't know if you have any questions. Okay, if there are no more questions, then I'll see you in 2 weeks. There will be another announcement on Discord. And in the meanwhile, you are welcome to explore Scala on your own as a language, the language features. And during the subsequent seminars, we are going to be covering the interaction with various APIs, with various libraries, how is that organized, and how you can use Scala to actually build stuff locally on your machine. So thank you very much for attending, and I'll see you during the next session. Have a great week. Bye-bye.